Forget the marketing buzz. Today, the focus is on the raw engineering of the Leapmotor D19. This is not a car with a simple air tank. It is a full-scale pressure swing adsorption (PSA) system integrated directly into the SPA3 platform. While most EVs focus solely on battery chemistry, this architecture focuses on atmospheric chemistry. It utilizes dual molecular sieves packed with lithium X zeolite. The system intakes ambient air, compresses it to 0.2 megapascals, and forces it through the zeolite bed, which traps nitrogen molecules and allows 93% pure oxygen to pass through. It's a continuous, self-sustaining cycle that turns the D19 into a mobile oxygen factory. Looking at the chassis schematic, the OC Mod 01 oxygen module is housed behind the front firewall on the passenger side. This specific placement serves two functions: vibration isolation and thermal synergy. The 2 kilowatt microcompressor generates significant heat, which is tied directly into the vehicle's liquid-cooled thermal management loop. In cold weather, the waste heat from oxygen production is repurposed to precondition the 80.3 kilowatt-hour battery pack. To maintain a premium cabin experience, the compressor sits on dual-stage hydraulic dampers, suppressing NVH, noise, vibration, harshness, to less than 35 decibels. The system is silent, but the physiological benefits are measurable. The third lung emergency protocol is where the engineering becomes life-critical. In standard operation, oxygen is diffused via the A-pillar and B-pillar vents. However, the REF EO2L line, the red circuit, is a dedicated survival path. If a cabin pressure drop occurs or if the seat's biometric sensors detect a medical crisis, the system switches to high-pressure direct injection. A 120-bar buffer tank stored under the center console bypasses the mixing valves, delivering medical-grade O2 directly to the nasal cannula ports on the B-pillar. This is engineered to provide 10 minutes of life-sustaining flow, even if the main high-voltage battery is compromised, thanks to a dedicated 12-volt backup capacitor. This system is governed by the dual Snapdragon 8797 compute cluster. The internal sensors monitor CO2 parts per million ppm in real time. If the driver shows signs of fatigue, a condition often linked to CO2 buildup, the AI automatically increases the O2 concentration to 23% to sharpen cognitive function. The integration with the Navigate On Autopilot, NOA, is the most advanced safety feature. If the biometrics detect the driver has lost consciousness or suffered a cardiac event, the D19 simultaneously triggers maximum oxygen flow, engages hazard lights, and performs an autonomous emergency pullover using the LiDAR array. The powertrain and the life support system operate on a single unified nervous system. In the world of high-end EVs, luxury is usually defined by leather. In the D19, it is defined by the air the passengers breathe. By controlling the molecular composition of the cabin, Leapmotor has addressed fatigue driving at a fundamental biological level. For global EV insight, the takeaway is clear. The D19 is the first step toward biologically integrated transportation. This is the new benchmark for a flagship SUV in 2026. This isn't just a car, it's a technological guardian. The question remains, is this the future of every luxury vehicle? Let's discuss in the comments below. Subscribe for more technical breakdowns.